Good morning. So today's lesson covers the same topic as yesterday, which is 7.9c, but with one crucial difference. When we are calculating the area of a shaded region, we are actually finding a difference of areas rather than a sum. So we are looking at now a shaded region. And so we are going to be using a difference, or in other words, subtraction, in order to find the area of what I am shading in bright red instead of adding or instead of finding a sum. So let's go ahead and walk through this example together before you begin practicing today. So go ahead and draw the shape on your paper. And I have already shaded in the part that we are trying to find in red. So let's go ahead and think. What two shapes do we have here? Well, I see that we have a circle inside and we have a square outside. Well, which shape is larger? Well, the square is larger. Okay, which that's a terrible square. Let me try and make it look more even. So we need to find the area of both. But then we need to take the area of the circle away from the area of the square. So let's consult our reference chart to see what formulas we need. So we have our square drawn out and we have our circle drawn out. So I see that the area of a circle is pi r squared. That was for the last problem. And the area of a rectangle or a parallelogram is base times height. So remember, our square is multiplying the base and height together, and the circle is pi times the radius squared. And so now that we have found our formulas, we have now a note to make that this is also the reminder of a square, just in case we forgot. But we also know that since the square is a type of rectangle, we can use our formula area equals base times height. So just in case you were confused on where I got that formula, please make note that a rectangle or a parallelogram also includes a square. So now we can go ahead and make an expression that helps us find the solution, because once we find the area of the square and find the area of the circle, we want to find the difference between the two areas. So what operation would that look like if we were using our shapes? Well, I need to take the circle's area away from the square's area. So this would be subtraction to get us the shaded area or the shaded region. Okay, so now our plan looks very similar to yesterday, except with subtraction. So everything else, we can go ahead and follow how we did yesterday by filling in our formulas with the values from our diagram. So our base and height of our square is 10 centimeters. So I can substitute that in here. And then if I look at my circle, I know that we need the radius for the circle, which is the halfway part when we cut the diameter in half. So this right here is the radius. Well, I see here that if the length is 10 centimeters, what does that mean about the length of the diameter? It would also be 10 centimeters, which is helpful, but it still isn't the radius. Remember, the radius is the halfway part. So if the diameter is 10 centimeters, what does that mean about our radius? Well, if we cut 10 in half, that is 5 centimeters. So I'm going to put that into my circle, that our radius is 5 centimeters. So we can now substitute that into our formula. Alrighty, so now that we have our dimensions, we can go ahead and start solving the formulas each. So let's start with 10 times 10, which I know is 100. So the area of the square, S for square, is 100 centimeters squared. And then if I go to the next one, I see that it's pi and then 5 squared, which would be written as 5 times 5. And so when I multiply 5 times 5 together, I get 25. And then we now can multiply 25 times pi. So even though on our formula chart they tell us pi is about 3.14, because we are in review time, we can actually use 3 for pi in these situations. Just because sometimes the problem will use 3.14 and sometimes it will use 3. But regardless, we will always find an answer that is close when using pi equals 3. And that makes the math just a lot easier. So let's go ahead and multiply 25 times 3, which I know is 75. So the area of the circle is about, let's just keep our approximation, 75 centimeters squared. Okay. So now that we have found the area of the square and the area of the circle, how do we find the area of the shaded region again? well, we need to subtract. And so I see that the shaded area is 25 centimeters squared. So let's stamp that our plan is very similar to what we did yesterday with area of composite figures. So the first thing we did was identify the shapes given in our figure. We then broke it apart with the matching dimensions. We found the formulas from our star chart. We substituted and solved, and then we subtract to find just the shaded region of this figure. Let's go ahead and try some more on our own.